All right, so who am I? I'm Olga. If you try to learn my last name, you'll get a free beer from me. It's pretty much impossible for Swiss people to pronounce. I work, huh? Close enough. Yeah, maybe half a beer. All right, that's a beer. That's a full one. All right. Yeah. Cool. So I work as a software engineer on different things, front end, back end. Yeah, just throw things at me. I will probably make something out of it. I don't have anything pretty like Xia has. I'm gonna talk about mostly problems and issues that I encountered while doing this. And so, what the hell is this, right? So, if we talk about the use case, I would say that this is a typical use case, right? So you want a website that can scale, that has really cool reactive UI, that is SEO friendly, but you have no idea how to manage servers. That's basically the story of my life, right? I work at HomeGate. And HomeGate, you guys know what it is, right? Most of you. So real estate platform, one of the biggest in Switzerland. So we have around 100,000 listings online, sometimes more. So it's pretty big. And basically, a lot of users visit this website and they go to the detail page to see the listing, right? So this is exactly the thing that is supposed to scale. It's supposed to actually look better than it is currently on the screenshot. And the current state of things at HomeGate is that this thing, like the whole application, is done in the old school way. So it's an on-prem server. It runs some Java. It runs the absolute dinosaur thing that renders front-end server-side. That's called Apache Wicket. Never use it. I tried it. I never again. And the whole dynamic things that you might get in browser is done with, guess what, jQuery, right? So is it sexy? It isn't. To the right, you can see what we're trying to achieve. So we're trying to move the system to newest technology to speed up our development life cycles. And this is our goal. So we want to go and move basically all the maintenance to Amazon. And instead of maintaining our own servers, just pay incredibly huge bills every month. And we also want to use newest front-end frameworks for doing front-end. And yeah, right, everything is JavaScript because what else? So the first, we did a proof of concept, right? That's what I'm going to talk about. The first thing that we started with is basically writing a universal app with Vue.js. Has anybody ever server-side rendered Vue.js? Except Alexei. So I haven't, so it was pretty new to me, and then I started. So as with most things front-end, there is more than one way to do it. You can follow the official Vue.js guideline, that link to the left, which is a very detailed step-by-step guide on how to set up everything from scratch with bundling and whatnot. And if you're not a masochist, you might want to go for Next, which is things that it says on the slide. It's a minimal framework, which basically takes care of everything you might need when writing universal apps or server-side rendering, static sites, and so on. So this is how we experience the setup, right? So with do-it-yourself approach, it's been several days of actually reading, webpacking, swearing, and we still didn't solve all the things. So basically, the app I'm going to show at the end, it does server-side render, but developing it, it's not very comfortable because we still need to solve the hot reload. With Nuxt, it's basically that, right? So you do this and you start and you're ready. But turns out that if you suffer through the whole do-it-yourself thing, you basically have the setup that you can do anything with, right? So you can write the Vue.js app as you used to, put your route configurations where they belong, and that kind of things. If you do Nuxt, you have to learn Nuxt on top of the Vue. So you have to adopt a certain project structure. If you want a fancy Webpack loader, let's say for your SCSS or something like that, or in our case, it's TypeScript, you have to configure it in Nuxt config, which has a different style of configuring things than normal Webpack, so you have to learn that on top. And on top of things, you also have to use Nuxt-specific versions of everything Vue.js, all the extensions, right? So for example, if you're using TypeScript and you would like to benefit from Vue class component, no way, you have to use Nux class component because the previous one's just not going to work. And so on. We hit a lot of problems with that. So there are also some learnings. Apparently, not only the setup is tricky in this case, you also have to think about how you write your code in Vue.js. So surprise, surprise, there is no data reactivity on the server. So if you run some of the code on the server and you expect it to run without throwing any errors, it shouldn't be data reactive, right? So just no watchers in the server code part. And the only lifestyle hooks of components that run on both sides, so also are able to run on server, are before created and created. Everything else, again, because there is no reactivity, is not going to happen on server. So don't rely on it. Also, the thing that I didn't think about, but now it seems pretty obvious, is that there is no window and document on server because there is no browser. So everything that has to do with manipulating this stuff like carousels, pop-ups, whatever, forget it. It's not going to happen on the server. But again, what can you do with that? You can still use that, but render it on the client side. And to make sure that your server doesn't throw exceptions while going through that part of code, you can wrap those components that rely on these things into something like Vue SSR. It's a tiny NPM library that does a very simple thing, which you can also do yourself, but with libraries a bit cleaner. And then you can basically have the code that is only client-side marked with this, and everything would be fine. And same goes for directives that are accessing non-virtual DOM, right? So either replace them with components or provide some server-side versions that kind of are dummy versions of these directives. So on server-side, you do not do anything, and on client-side, when your app is up and running, just do these things. Given that normally you would use SSR to just boost your SEO friendliness, right? So you would just basically need to have some data rendered, and you don't really care about like all the fancy interactions. I think this is still going to be usable, right? So even if you reduce the amount of things your server can do, you can still fetch some data, you can still render it somehow and send it back to client, and then start building all the rich interaction thingies that crawlers don't care about. So I think it's still pretty good. Yes, challenge number 2, putting it into cloud. So how do we do that? So this is me a little while ago. Anybody else like that here? It's fine, it's okay, yeah. It's an inclusive space, so I didn't know anything about that. I learned a little bit about the AWS services that we're using in HomeGate, and I actually am loving it, as you can see from the stickers. So basically what serverless is, I heard this once from some AWS evangelist that I cannot remember, also from the conference that I cannot remember, but it's a really good description. So basically it's super easy, it doesn't matter what you use, but serverless is when you only pay for the computing time that you consume. Like, if it doesn't work, you don't pay for it. And then it doesn't matter what you use, Google Cloud, AWS, Azure, some open source stuff, this is it. So quick recap, these are the services I'm going to be talking about. So in case you don't know them, take a look. So it's basically AWS Lambda, function as a service from Amazon, API Gateway, a service that allows you to configure your APIs, and S3, I think everybody knows it. It's a highly accessible storage that never fails and is super cheap. So the first idea how to put the things together was like this. So we wanted to kind of be as close as possible to the classic way. So the browser basically sends requests to the API. Lambda function performs the server-side rendering while fetching the data from storage and sends this string back to browser through the API, right? So it happens on the fly. Obviously, there's going to be like a caching layer in front of the API so that you do not server-side render every single request, because that's crazy. But for the sake of argument, this is basically it. Right. The only problem that I see with this configuration is, well, the only 2 problems that I see with this configuration are the cold starts with lambdas. So the guys who use lambdas, they know that every time like it hasn't been working for a while, and then you spin it up, right? The container starts and it starts loading your code base. It basically takes a while. So even if your code is really fast, this cold start, if your package is big and you have to install a lot of stuff, it could be a real killer. So that means that it could slow down your page, the first load of it, until it's cached pretty badly. And the second thing that is more like less of a problem and more of a hassle is that you have to somehow manage static assets of your website, right? So you either have to upload them somewhere and then orchestrate the deployment of your Lambda and these assets, and basically either write a complex deployment pipeline or use another service to do that, blah, blah, blah. Or, as I've seen actually some people doing it, you put an Express.js server inside of a Lambda and serve everything from there, including pictures, fonts, to basically proxy all kind of requests. But I think it's stupid because it's supposed to be serverless, right? Bad enough that it actually has physical service behind it. You're also putting like a logical server into function of the service. It kind of defeats the purpose, right? And also, I'm not sure if it's super slow because Express is tiny, but yeah, kind of yeah. So the second idea we had is basically complete pre-rendering. Like, this picture looks a bit crazy, but hear me out. So the idea is that as soon as the new property gets published or edited on the website, which happens much less frequent as the users actually try to view them, we basically call the Lambda function there, right? So it does exactly the same job. It fetches data, it server-side renders, but instead of serving it back to API gateway and caching it, it just dumps everything on the S3 static, on the S3 bucket. And S3 is a service that could be configured to serve a static website. This is like out-of-the-box functionality, and it's super cheap, it's super fast, so it requires maybe a couple of clicks in the console, and yeah, this is basically it. The benefit of this is that you have everything in the bucket. It's easy to version, right? So if you're deploying a new version, it could be a different pass in your bucket, and yeah, also no hassle with cold starts, basically, because every time you have something new on a website, you take your time, you can render it as long as you want, and then you make it available for users. The biggest problem with this is that if you want to make your logo bigger, right, and it includes a change not in the logo image, but also in the code, you basically have to render the whole crap that you have there. So, yeah.
Because they are static.
Because they are just HTML files lying on S3, right? So, again, still not sure about which way we're gonna go, but this is it. So I have a little demo that we built when we were trying that out. So of all the approaches that I just mentioned, we took the most stupid one with the Express server inside the Lambda. But yeah, this is the most stupid one. It's the most slow one, but actually it's not as bad as we expected it to. So apparently if you improve that, that's gonna be even better. So what am I gonna do? I'm just gonna, I don't know, probably make sure that I can deploy it. First, I'm gonna change the stack name. So this is the whole app, right? We deploy it with serverless. This is the framework for deploying serverless stuff. So it doesn't only work with AWS, I think it works also with different other clouds. So I'm gonna call it Web Zurich Demo, because I think I had the stack with that name already. And I'm gonna do the yarn deploy. Hopefully it doesn't crash. So I'm deploying it to the cloud. Should be pretty quick because it's just one function, one API. It has to package, and then serverless tree shakes the dependencies to not include development dependencies. So the first deployment takes a while. The subsequent deployments, when you only deploy like a little change, it analyzes, serverless analyzes, and just deploys the change set. So it's going to be a bit faster. But, you know, wanted to make an honest demo, so it's the first stack. Watching the grass grow. Am I still online? Come on, serverless, don't embarrass me.
Can I ask you?
Yes, it's finished.
Generally, why do you choose Vue.js, not Angular with Universal together?
We had actually a proof of concept with Angular and Universal. It's on my GitHub. You can check it out if you want. My personal preference is Vue.js because it has this is designed to work with this Redux kind of pattern or Flux kind of pattern if you want. Yeah, but for Angular, it kind of have to bring it in, right? So it's not that easy. For Vue.js, it's the thing that they support, and the thing is built for it. It's reactive, and yeah. I'm not gonna go into discussion Vue versus Angular yet again. So if you will like, yeah, we can do it afterwards. But yeah, we actually had proof of concept because some of our coworkers, they were pro Angular, some they were pro Vue. I was pro React. I obviously lost, so Vue won, and that's the result.
What did you take as measurements and have a clear position? What was the point where you measured which solution invests?
Like if we're talking about technical things, they are pretty much going head to head, right? So you can use either one if you only care about performance and these kind of things. The other aspect that we had to look at are the skills of our current developers, right? It was much easier for them to pick up Vue than to pick up Angular. Yeah.
Well, you also used before.
React, they didn't even want to hear about React for some reason. I don't know. Yes. So that's the story. Okay, so basically it finished deployment, and I'm gonna go to AWS console to find the stack. There it is. It says update in progress. No, it's actually complete. So this is the stack. These are resources that have been deployed. So a couple of rows, couple of policies, REST API, and actually Lambda function. I'm gonna open it because we're gonna need it later. And this is the link to our API. So this is basically the app, which is absolutely fancy. You see how long it takes the first time? If I refresh it, it's going to go through the server again, but it's going to be much faster. So what this app does, it fetches this property from an API, and server-side renders it. It has two routes, and this one is the code that basically opens a pop-up, which, as we know, cannot be server-side rendered, so it's only enabled on client-side. For example, if I disable JavaScript right now and try to refresh this, there'll be no button because Vue.js didn't kick in locally, right? And there is nothing there. It's just everything that comes from server, it's just this. Or in case of this route, just this. Just to, prove that I'm not lying, this is source, right? So you can see that the data is already there. Right, so this is it. Let's call this thing a couple more times, this Lambda. And then we can basically jump to the monitoring. I'm kicked out of my account. That's AWS console. It has a very good interface. Let's take a look at the duration of Lambda, right? So this is a metric view. It's a bit hard to use. We don't have much data, so it doesn't draw us a graph. But we have three different colors. One is for minimum duration, this is for maximum duration, this is for average, right? So you can see that maximum duration is around actually 4 seconds in here. Minimum duration is 2 milliseconds. And the average is about half a second currently, right? So this is something that you're getting with this worst case scenario express thing in Lambda that probably we're never going to go with. So to have an idea of how much that could cost in comparison to the normal server, I would take this average duration of 534 milliseconds and go here. Our Lambda settings here, I need to check the memory we've allocated for it. It's somewhere down there. It's 124 megabytes, right? So I'm going to put this here because depending on how much memory you allocate, the costs go up. Let's look at 1 million server-side rendering requests per month and say that we have 534 at average execution time and just see how much that costs. That costs $2 per month. It's not 2,000, it's $2. It's a bit confusing with this dot, but yeah. So Yep, you can do this. Right.